Okay, now we are ready to understand GloVe. So GloVe model actually first constructs not a single vector, but two vectors, right? So in GloVe, we first assign two vectors to a word, right? So if we have a word, then we're going to construct the word vector in RD, and we're going to construct this so-called context vector tilde W, which is also a d-dimensional vector. So we want to find a function f of three vector arguments. So f is a function from basically wi is a d-dimensional vector, wj is a d-dimensional vector, and that the tilde wk is also a d-dimensional vector. So we are looking for a function from the Cartesian product of three copies of RD to real numbers. Well, to positive real numbers, because we want probabilities. Right? So generally speaking, so we want to find a function that somehow captures these probabilities. I'm sorry. Yeah, okay. But then we need to reflect the vector space structure on RD, right? So, which is why instead of just looking for f that is any function of three vector arguments, we want it to only depend on the difference of target vectors, right? So we are going to construct a vector of a function of two vector arguments, such that if instead of the first argument we plug in wi minus wj, then we get what we want. All right, but then let us think a little bit further. So the input of this function f is two vectors, and the output is a scalar. So do we know of any function whose input is two vectors and whose output is a scalar? And we do. It is the dot product. So which is why it is convenient to, instead of again trying to consider all possible functions f, we're going to try to find a function f that actually depends on the dot product of these vectors, right? So instead of a generic function f here, I'm going to construct a function f with a scalar input and scalar output. Moreover, its scalar output is actually not just any scalar output, but a positive scalar output, right? So I want my function to have an arbitrary scalar input and the positive scalar output. Okay, so we are looking for a function that satisfies this property, right? But then we're going to rewrite it. So this is actually f of wi transpose wk tilde minus wj transpose wk tilde, and this should be pik divided by pjk, and it's kind of symmetric, right? So if we switch I and j, so the right hand side is just flipped over, so we get the reciprocal, and the input of the function is just replaced with with a negative the input. Well, but then this is something that resembles a homomorphism, right? So basically, our function should kind of transform the minus operation to the division operation. But then minus is sort of a reciprocal to plus, right? And division is reciprocal to multiplication, right? So we are looking for a function that transforms addition to multiplication. But what is a function that transforms addition to multiplication? It is a homomorphism from the additive group of real numbers, from real numbers considered with the plus operation as the operation, to the group of positive real numbers, well, positive because probabilities are positive, with the multiplication being the operation, right? So we really, it is going to happen. So this nice property is going to automatically happen if f is a homomorphism from the group of all real numbers with the addition operation to the group of positive real numbers with multiplication operation. Right? So, and in that case, we're going to have this property. So, and in order to ensure this, we should just require that f of, well, basically, this is what we want to require. So this is going to happen if f of wi transposed times w tilde is just pik. And pik is xik divided by xxk. Right? So what is homomorphism from the additive group of real numbers to the multiplicative group of positive real numbers? It is a very well familiar exponent function, right? Because, well, exp of x plus y is exp x times exp y. So exp transforms addition to multiplication, right? Which is why it is convenient to set my our f to be the exponential function. So which is why it is convenient to require that f of wi transposed tilde w, okay, is just exp of this wi transposed wk tilde, right? But then it means that at the same time, this is supposed to be equal to x, what's it? It's xik divided by xk, xik divided by xk, right? So we have this relation, and we're going to just apply the log to both hand sides. Log of x is the expression inside the x. So we're going to apply log. Log of x is just the expression inside the x. So we will get wi transposed tilde w, okay, equals logarithm of the ratio is the difference of logarithms. It's going to be logarithm of xik over xk, which is logarithm of xik minus a logarithm of xk. And this is what we want to achieve by finding suitable vectors w and w double k, right? So this ideally we have this. Well, so notice that this does not depend on I, right? So we can just denote it by b tilde k. And this is going to be a bias. It's called a bias. Well, at the same time, the roles of the word vector and the context vector are interchangeable, right? So because you know, we have seen that the word co-occurrence matrix is symmetric. So whenever word I appears in the context of word j, then word j appears in the context of the word I. So, and in order to restore this symmetry, we're going to introduce another bias for I. And finally, we're going to get this. This is the ideal situation, right? So this is sort of the ideal. So which means that in order to make our word vectors to be as close to the ideal as possible, we're going to just subtract. So wit. Well, we're going to just move this to the left hand side. So wit wk tilde plus bi plus bk tilde minus log of x ik should be equal to 0. But then we are going to square this because something equals to 0 if and only if its square equals to 0, and then we're going to minimize it instead. And this is basically how we train GloVe. So we're going to minimize this loss function. So the only change is that we're going to minimize not just the sum of squares, but we are going to multiply it by a suitable weighting function chosen carefully to avoid overweighting two rare co-occurrences, right? So if the two words occurred together only once or twice, then we probably do not really give too much weight to this, because it could happen just by chance, right? And or if some words co-occur very, very often, then again we don't really overweight it, right? So which is why instead of just taking the sum of squares, we're going to take the weighted sum of squares. Well, and doing this will give us word vectors and context vectors. So, and the final word embedding is going to be just the sum of the two. So here is a small example. So if this is our corpus, two documents. So I have trained the model for 5 epochs with window size 2 and 2-dimensional vectors. And here is what I've got. So these word vectors themselves, they cannot really be interpreted. It doesn't really make sense. I mean, what does this mean? It's just a number, right? But then we can compute the cosine similarity between any two words. Yeah, and in real setup, if I trained my GloVe on a large corpus, then words that have similar meanings, they would have high cosine similarity, and words that they have really different, unrelated meanings, they will have cosine similarity close to 0. Well, and this is how I can plot it, right? So if I only have two-dimensional vectors, then I can just plot them and look at them. And again, for a small corpus, it doesn't really make a lot of sense. It's just some way how you can visualize it.